Hello everyone, this is me Rajeev Nepal. I am a graduate student at Morgan State University. I work Dixon Research Center as a research assistant under supervision of Professor Ramesh Chandra Budani. I would like to introduce my team. Sin Davis, he is a graduate student who work in our lab, and Vinay Sharma, he is the senior postdoc researcher at our lab, and Ramesh Chandra Budani, he is a professor and we work under his supervision. Today, my presentation topic is deposition of high quality ferromagnetic epitaxial thin film on single crystal MAO. So this is the outline of my presentation. It will cover introduction and motivation, experimental method, result and discussion, conclusion and acknowledgement. So this is the introduction and motivation of our research. We choose iron cobalt film to deposit on MAO. So we choose iron cobalt because it is familiar for that distinctive character like high saturation magnetization, low coercivity, low magnetocrystalline anisotropy, and high Curie temperature. So due to this, its high saturation magnetization and magnetocrystalline anisotropy, it is widely used in making magnetic random access memory (MRAM). So we have used concentration of iron as 75% and cobalt as 25%. This cobalt concentration generally increases the hardness in the solvent. So it is required to fabricate soft magnetic thin film with high crystalline nature. So we have chosen MAO substrate to fabricate this single crystalline iron cobalt film with high saturation magnetization and low coercivity. Magnetocrystalline anisotropy has been quantified using angular rotation of magnetic films in BSM. So this is our experimental setup, and this is the UHV sputtering system. It consists of two chambers. This is the load lock chamber, and this is the main chamber. Our film was deposited at main chamber, and you can easily see that there are four DC magneto sputtering gun. Two of them are clearly visible from this angle, and two of them are other side. We use DC power source for our gun, and the deposition was done mainly in this main chamber because in main chamber we can achieve the base pressure of around 4 into 10 to the power minus 8 milliliter, and we have deposited iron cobalt on MAO with tungsten capping. This film has high saturation magnetization, soft magnetic property, and four-fold magnetic anisotropy. For the substrate, we use 5 mm by 5 mm MAO substrate for our deposition. We made 4 sample and where we kept iron cobalt thickness at 6 nanometer, which is constant for all 4 sample, and tungsten thickness is varying from 1 to 5 nanometer. Iron cobalt films were deposited at 180 watt at 350 degrees Celsius. We use a high temperature to achieve good epitaxy, and this film were deposited using DC magneto sputtering gun. And for tungsten capping layer at stabilized beta phase, we use a target power of 40 watt, and it was deposited at room temperature. The deposition rate for iron cobalt was 0.82 Armstrong per second, whereas the deposition rate for tungsten was 0.33 Armstrong per second. Uh, the tungsten is deposited at slow rate compared to this iron cobalt, and these film are deposited with presence of argon with pressure 5 milliliter, and flow is maintained. The flow of argon is maintained at 4.6 SCCM. So this is the BSM to measure our static magnetic characterization, and we use this probe to mount our sample, and this room temperature stress, this angular scan are measured by using this vibrating sample magnetometer BSM devices, and we can get some diamagnetic contribution using this device. So this diamagnetic contribution of the substrate was removed using slope calculation, and MS loop were measured by applying in-plane magnetic field. So this is our M by H graph, and this is the X-ray. we can clearly see the peak at around 65 degree. 2 theta is 65 degree, and this graph shows that it has high saturation magnetization, which is around 2.5 something. So X-ray diffraction analysis of this film shows that iron cobalt preferentially with having BCC structure, and lattice parameter of this iron cobalt was found to be 4.03 Armstrong, with average grain size was found to be 75 Armstrong. The saturation magnetization and coercivity of iron cobalt 6 nanometer with tungsten 1 nanometer was found to be 2.51 Tesla, and coercivity was 3.4 millitesla respectively, whereas the saturation magnetization and coercivity of another sample with iron cobalt 6 nanometer and tungsten 5 nanometer was found to be 2.64 Tesla and 3.47 millitesla respectively. Single crystalline iron cobalt film are showing soft magnetic nature with very low value of coercivity. We can clearly see from this graph that the value of coercivity is quite low. It is around 3.3.4, 3.5 millitesla. So this is the angular scan at different field. We can clearly see that four-fold symmetry for the 50 oersted field, and again four-fold symmetry for 1000 oersted field. But this four-fold symmetry was removed when we apply 1000 oersted scan. So all this scan reveals that our sample has four-fold symmetry at 50 and 100 oersted field, whereas it has two-fold symmetry for 1000 oersted field. So the conclusion of our research is this study established that we can deposit highly epitaxial film of iron cobalt having soft magnetic property and large saturation magnetization using DC sputtering method. And MAO substrate is good choice to deposit single crystalline iron cobalt thin film with high saturation, magnetization, and low coercivity. As you see in my previous result, that we achieved the high saturation magnetization and the coercivity was quite low. It is around millitesla, and the saturation magnetization was in Tesla. So structural characterization reveals that iron cobalt grows in 001 preferential orientation with cubic phase. Angular scan of magnetization revealed that induced magnetocrystalline anisotropy in this film. So this is all about the conclusion of our research. So I would like to thank Air Force Office of the Scientific Research, because this research has been supported by the Air Force Office of the Scientific Research through grant this FA 95501910082. So this is all about my presentation. Thank you.